Hey, so in Unit 1, we've been learning more about area of rectangles, parallelograms, and now triangles. Well, I would like to review where we're getting our information from and where it connects. Hopefully you guys can all tell that this pink rectangle has an area of 6 square units. I could label the sides. It has one length of 3, and then another length or a height of 2. And you can count that there are 6 full squares in there. And it's the same thing over here. They're identical. 3 by 2. And so it seems obvious that you can take for a rectangle, to find the entire area, you simply multiply one dimension by the other. And the key is that they meet up at a right angle. That's how you can measure squares and see squares, because they're all built out of 4 right angles. Okay, so then we moved on to parallelograms. And for parallelograms, we can still figure out the area. We learned to decompose and rearrange them. So how did we do that? We did that by doing lines where if we drew a line vertical to the base at a 90-degree angle perpendicular, we could cut this triangle off and then place it over here. Now, why did we do that? We did that so that we could create a rectangle and still note that it has a base of 3, although if I cut this, it's from here to here. That's your base of 3, and it has a height of 2. So basically, this is the same thing. For a parallelogram, to find the area, we just do base times height, which is similar to a rectangle. That never changes. Even when you push over more and more these parallelograms, it's still the entire base, which in this case is 3, times the height. You can picture if I put a vertical perpendicular line here and cut, this triangle could be placed right here and it still makes a rectangle. Okay, now here's where you guys are getting confused. If I had cut this parallelogram into 2 equal triangles, I can go from this vertex to this vertex. Now, what did I just make? I made 2 triangles that each have the area equal to half of the given parallelogram. So if the parallelogram is figured out by knowing that 3 times 2 is the area of 6 square units, then the triangle, by virtue of being half the size, has to be 1/2. So I'm going to draw, using my straight line, a line from here to here that represents the height. And so it's got a height of 2. So it's still 3 times 2 is going to be how I would find the area of this parallelogram, but it's a triangle. So for a triangle, to figure out the area, it seems obvious to me that it has to be 1/2 of the base, which in this case is 3, times the height. Because if I didn't take half of it, then I would just be finding the area of the parallelogram, which is not the same amount of space taken up as just this triangle. So for a triangle, it's 1/2 of the base, 3, times the height, 2. Now, another way to figure out half of something, as we know, is to divide it by 2. So this is the same thing as 3 times 2, base times height, but then divided by 2. Okay, so hopefully this made sense, and if it didn't, let me know. Ciao.